Spindrift is the way to go, which is why we're learning about equations and inequalities today to prepare for MCAS. Y'all already know the vibes. Let's hop in the video. Welcome, everybody. Here we have our two forms of two-step equations. Here we have px plus q is equal to r, or p times the binomial x plus q is equal to r. So we call this a binomial because it's two terms. X plus q is just two numbers, right? And so before we get into reading here, I just want to say this hashtag symbol just means number. So our p-value is our multiple occurrence, number of people, number of items, or just our unit rate, maybe the price. X is our unknown, it's what we're looking for. Q is our one-time occurrence, known amount, or number of original items. And then finally, R is our total, or usually when we do inequalities, is our end goal. And so let's move on to example 1. Welcome, so let's do example 1. Giselle's Youth Club sells cookies to fund their trips and activities. Each year, they need to earn $1,247 from selling cookies. For each box of cookies they sell, they make $1.45. If Giselle's club has already made $472.70 from selling cookies, how many more boxes do they need to sell to meet their goal? Well, first off, let's annotate this problem. So instantly I can see each year they need to earn 1,247. Looking at the key we made up here, we can see if they need to earn 1,247, that's our end goal. So what that means is that this will be our R. And so what I like to do is I like to make my key here and put 1,247 over into my key. Now, we got that from selling cookies, right? For each box of cookies they sell, they make $1.45, right? This is one or two things. This could be your unit rate or your, right? It's just our unit rate. So we make $1.45 each box. So what that means is that this will be our unit rate because that's how much we're making per box, right? Keywords, how much we're making per box. And so this would be $1.45. And then finally, our last number, if Giselle's club has already made, keywords already made, $472.70, that is what we know we made. We know we already made that. And so that makes this our Q value. So that means this would be $472.70. And so now we need to ask ourselves, is our Q value and our X kind of lumped together? Or is our X and our P their own little kind of separate entity? Well, here we know we make $1.45 per box. So that tells me the P and X are actually connected in this scenario. So what that means is I know I want this form here. And so I write my form, right? PX plus Q is equal to R. And the keyword why this is an equation is because we want to know, right, how many more boxes do they need to sell to meet their goal? We want the exact number. And so we use an equation. And so I just substitute P with my numbers, right? $1.45 times the amount of boxes we need, right? Because that's our unknown. And so times X plus our known amount, which is just $472.70, and that is equal to 1,247. Luckily on MCAS, it's probably an MCAS question. This would probably be a calculator question. So we're going to use our calculator for this because we want to focus on the algebra. So actually, I will not use a calculator because I want to show you how to subtract with decimals. So here, I like to draw a line to organize the math. And so we need to do reverse PEMDAS when solving a two-step equation. What we see here is if I was to write PEMDAS up top, right, you want to start from the right and go to the left when solving a two-step equation. So that means adding or subtracting first. So the inverse operation to addition is subtraction. So I need to subtract 200 $472.70 from both sides. And so what ends up happening is these are additive inverses because they're opposites of each other. So I cross that out, and then I need to carry down my $1.45 times x and set that equal to whatever 1,247 is minus $472.70. And so when I do this, maybe I do this on the side. So 1,247. I line that up with my decimal. Notice how this is 400. So I line up the 400 in the hundredths place. So this is 472. We see all place values line up. The 2 is in the ones place, so I line up the 2 in the ones place. And then my decimal is 70 cents. And now I need to subtract. Again, clearly, right, we have nothing here. So this is when we can add a decimal in zeros at the end of our number because that won't change the value. And so let's subtract 0 minus 0 is 0. Obviously, you cannot do 0 minus 7 here because in the algorithm, you need to make sure that your number on top is bigger. So here we have to regroup our 7 and make this a 6 and make this 10 tenths. So 10 minus 7 is 3. Bring down our decimal. 6 minus 2 is 4. Regroup our 1. Make 4 14. That's 7. And then for some reason, I always like to do this. 11 minus 4 is 7. So what that tells us is after what we already raised, we have $774.30 left to raise, right? Because we already raised this much, which means this is what's left to raise in our goal. And again, here we have 1 in 4, $1.45 times x. When you see no operation sign in front of the x, you need to divide both sides. And so I like to make a fraction on both sides because remember this bar here, this fraction bar is another way to say that we are dividing. So this fraction bar means we're dividing. So we divide both sides by $1.45. And so anything divided by itself is 1. So we're left with 1x. And it's equal to whatever $774.30 divided by 145 is. So maybe we set this up on the side here. So again, $774.30 is our dividend. So that goes inside. $1.45 is our divisor. So that goes on the outside. And so whenever our divisor is a fraction, whenever our divisor is a decimal, we need to make it a whole number. And so if I say this by place value, it's 1 and 45 hundredths. So since this is 1 and 45 hundredths, I know I need to multiply my divisor by 100 because it terminates in the hundredths place. And so I move the decimal place over to the right twice. And whatever I do to my divisor, I need to do to my dividend. And so I multiply my dividend by 100, which moves the decimal place over to the right 2 times, out with the old, in with the new. And so this becomes 145 divided by 77,430. And I don't want to spend too much time showing the division here because we did the hard part of showing the rule. And so 77,430 divided by 145 is just equal to 534. And so what this tells us is that we need to sell 534 boxes. Bam. Let's go to the next one. All right, I don't want to spend too much time on this problem just because it can take a little bit and I want to make sure to get to inequalities. So I kind of already set it up for us. So a museum sells 3 types of tickets, including those for seniors, adults, children. On a Tuesday morning, the museum sells 164 tickets. The number of adult tickets sold was 3 times as many as the seniors, right? 3 times the seniors. And the number of child tickets sold was 10 more than the adults. 10 more just means 10 plus the adults. How many type of tickets does the museum sell on Tuesday morning? Use either a tape diagram or equation to represent the situation. So why do I have X for seniors? Because nowhere in this problem did it tell me about the seniors, which means that's my unknown. So that means seniors is X. And so now I can add that to our adults. Our adults was 3 times the seniors. I can substitute seniors with X. So this is just 3 times X plus the children, which is 10 plus the adults. Here's the trick here. The adults is represented as 3x. So I substitute the adults with 3x. So this is 10 plus 3x. And that is equal to the total amount of tickets sold, which is 164. Now, I need to combine like terms. What are like terms? They are terms that have the same variable and exponent. What we can see here is this 10 does not have an x attached to it. So that means this 10 is a constant, which means in this equation, it has no like terms. What are my like terms? Well, I have x plus 3x plus 3x. Why are these like terms? Is they all have the variable x with an invisible exponent of 1. So I can combine x plus 3x, which is 4x, and then 4x plus 3x, which is 7x. Bring down my plus 10, and that is equal to 164. And so now we need to solve for x. What do we get when we get x? Well, we get the number of seniors that bought tickets. So again, I subtract 10 from both sides. We already learned about reverse PEMDAS. Carry down the 7x. 7x is equal to 154. Divide both sides by 7. I'm left with x is equal to 154 divided by 7. So maybe I do that on the side real quick. 7 goes into 1 0 times. 7 goes into 15 2 times. 15 minus 14 is 1. Carry down my 4. 7 goes into 14 twice. And so that just means my answer is going to be 22. What does that mean? It means that 22 seniors bought tickets. How many adults bought tickets? Well, 3 times the seniors. So what's 22 times 3? It's 66. And then how many children bought tickets? Well, it was 10 more than the adults, so that was 76. And that was our staple middle school problem in 3 minutes and 30 seconds. All right, so here we have our notes for inequality symbols. Here are maximum and our minimum. We still have our 2 forms here. Again, you can use any inequality symbol here. I don't want to fill up the space. Please pause the video and copy down our key. And so here we have greater than or less than. And so what graphing inequality notes, what do you use when graphing? Well, if it's less than or greater than, you want to use an open circle. Why? Because your answer is not included in the solution set. You want to think of this as your answer falling through this hole because you have to have less than or greater than that amount. You can't have equal to that amount, which is why when it's greater than or equal to or less than or equal to, you use a closed circle, right? It's filled in. Why? Because your answer is included in the solution set. If it's x is greater than or equal to 5, 5 can be in your solution set. And so pause the video and copy these notes down. And so before we go on to example 3, I do want to let you guys know in word problems on MCAS, they're going to throw out words like maximum and minimum to throw you off because they're easily like to get confused because if you think minimum, you think less than. But minimum means you cannot pay less than that amount. So if minimum wage is $5, a company needs to pay $5 or more. If the maximum a bench can hold is 500 pounds, then that means that bench can only hold 500 pounds worth of stuff or less. So What that means is we're going to use this information to help us down here. So example 3, a local car dealership is trying to sell all the cars on the lot. Currently, there's 525 cars on the lot. The general manager estimates that will consistently sell 50 cars per week. Estimate how many weeks it will take for the number of cars to be fewer than 75. Let's talk about fewer than 75. The words fewer than means less than. So that means our R value is going to be less than 75. Why? That's our end goal. Well, let's go to where we see our other number. Currently, there are 525 cars on the lot. That's how much we know is on the lot. Since we know there's 525 cars on the lot, that means that Q is 525. Now, this problem goes a little different. Why? Because it's saying we're consistently selling 50 cars. So if you're selling 50 cars, is that going to make your inventory go up or go down? The answer is if you're selling cars, that means your inventory is going to go down, right? Because we want to like go below 75, which means that this is actually going to be negative 50. Why is it negative? Well, we're selling cars, so we're losing cars in our lot. And so let's make our equation. Let's ask ourselves, is X and Q connected with P, or is it really just P and X that are connected? Well, each week we're selling 50 cars. That tells me that P and X are connected and that Q is kind of a second piece to that. And so that means I want to do PX plus Q is less than R. Why is it less than? Because we're saying fewer than. And so here we want to do our equation. So negative 50X plus Q, which is 525, is less than 75. And so now this becomes a two-step equation. And so again, I want to get rid of addition or subtraction first. The inverse operation to addition is subtraction. So in order to get x by itself, I need to subtract both sides by 525 first. And so I have the additive inverse and can carry down my negative 50x is less than 75 minus 525. And so this is actually a good example. So this is 75 minus 525, also known as 75 plus negative 525. And so when you do this on the side, you want to make sure the number with the largest absolute value is on top. Remember, absolute value is the distance a number is from 0. And so since negative 525 is further away from 0 than 75, we want to put negative 525 on top plus 75. And we want to treat this like subtraction. So 5 minus 5 is 0. Regroup my 5 to make it a 4. 12 minus 7 is 5. Bring down our 4. This becomes, and our sum, or in this case the difference, right, whether it's positive or negative, depends on which number has a larger absolute value. The number with the largest absolute value is 525, which means our sum is going to be negative. And so this is negative 50x is less than negative 450. And so now what I want to do is get x by itself. So I divide negative 50 from both sides. And this is kind of the whammy. We're dividing by a negative. And so with inequalities and only with inequalities, when dividing by a negative, you want to flip the inequality sign. And so we want to flip. Why? We're dividing by a negative. So this becomes x is greater than. We flipped it. Negative 450 divided by negative 50. A negative divided by a negative is a positive, which means we need to sell cars for more than 9 weeks. And this makes sense, right? Because if you're selling cars, you can't sell cars for negative weeks. Also, you can't sell cars for fewer weeks, so it makes sense that we had to flip the sign here. So here our sentence frame is we need to sell cars for more than 9 weeks. Remember, explaining your work is important on MCAS, and let's move on to example 4. All right, welcome to our final problem. So here, identical copies of a book are being packaged and shipped to a bookstore. There are 18 boxes of books that each weigh 31 pounds. The boxes have space for some books to be added. However, the total weight of all the books cannot exceed 615 pounds. Two workers, Kevin and Olivia, want to determine how many more books they can add into each box without going over the weight limit. And so what that tells me is we cannot exceed 615 pounds, which means we can have 615 pounds or less. So that means that this is less than or equal to 615 pounds. What about RP? Well, remember, RP can be the number of items. How many items do we have? Well, we have 18 boxes. So what that means is 18 is our number of items, aka P, or in this case, maybe the multiple occurrences. Q is how much we currently have in those boxes. Each box is 31 pounds. We know that. And so since each box is 31 pounds, right, Q is our 31. And so if I have this box here right now, there's 31 pounds in each box. Now, what we want to do is we want to add some more books. And so this is why we want to ask ourselves, is X and Q connected? In this case, there are. Why? Because I'm going to be placing books into this box that already weighs 31 pounds. Do I know how much weight I'm adding? The answer is no. So that means I'm doing 31 plus an unknown amount of weight that I'm adding in books. How many boxes do I have? Well, instead of making 18 boxes, I know multiplication is repeated addition. And so I can group these and have 18 boxes. And again, this cannot exceed 615 pounds. And so that means this is less than or equal to 615. What we notice is we have a different equation here than we have before. Why? Because the Q and the X are connected in this scenario. And so now I need to solve for X. So this becomes 18 times the binomial 31 plus X, which is less than or equal to 615. Now there's two ways to solve this. Either you can distribute first and then do a two-step equation, or you can go right into doing a two-step. Remember, reverse PEMDAS, right? You're used to doing parentheses first, but in this case, multiplication or division comes before these parentheses. And what we can see is when you have a coefficient, right, on the outside, so this 18 is called a coefficient is because it's multiplying both of these terms. So I can get rid of that 18. And so I get rid of that 18 by dividing both sides. Why? Because this is 18 times the binomial. What's the inverse of multiplication? The answer is division. Remember, this fraction bar means division. And so 615 divided by 18, we're dividing by a positive, so we do not flip the sign. Since 18 is positive, you do not flip the sign. So maybe I do this on the side. 615 divided by 18. How many times is 18 going to 61? Well, I know if this 18 was a 20, it would go into that 3 times. So I can assume it goes in 3 times, right? I can estimate that. So 18 times 3. 3 times 8 is 24. Regroup our 2. That's 54. And so I regroup. 11 minus 4 is 7. That's 0. Carry down our 5. I know again, if, right, 18 goes into 61 3 times to be 54, I know 54 is too small, which means this probably goes in 4 times. So if I do 18 times 4, this would be a 2 and a 3. So this becomes 72. 75 minus 72 gives me 3. Again, I have nothing left to carry down. Ooh, I made a common mistake. I did not put 4 in my quotient. Don't forget to put 4 in your quotient. And so I have nothing left to carry down. So this is when I add a decimal, carry it up to my quotient, and bring down a 0. 18, we can see, goes into this 1 time. And so I can subtract 18. and this just becomes 12. I can carry down my 0. 18 goes in 120. Again, if this was 20, I know that would go in 6 times. So I can assume it goes in 6 times. So 18 times 6. I should probably just use the calculator for this. 6 times 8 is 48. 6 times 1, that's 10. So that's 108. And so finally, oh, wait, no, that's good. So finally, 120 minus 108 is 12. I can carry down another 0. And what we end up getting is that this is 34.1 repeating, question mark? Yeah. Let me double check this. Sometimes division can get kind of dicey. Huh, I did get it wrong. Oh, no, I didn't. I'm just a durkadur. This is a 6. Why do I keep putting it in the quotient? Dang. Right? Because 18 went to 126 times. So this is 34.166 repeating. So I'm left with 31 plus x. And so this is why this is probably a calculator problem. Well, interestingly enough, if I minus 31 from both sides, that works. So now I can, again, this is 31 plus x. So I want to get rid of what's around my x. That's this 31. You see how this 31 is positive? Since this 31 is positive, you need to do the additive inverse, which is negative. So we subtract 31 from both sides. And so again, this could be just 0, 0, 0. And so we're left with x is less than or equal to 3.16 repeating, which tells me I can add 3 books. Why did I say 3.16 repeating books? Well, you can't add 1/6 of a book. You just need to add 3 books and call it a day. And that is this problem. And again, I should show you how to graph it. So quickly, on MCAS, you'll be given a number line, and you'll be able to pick your points. In this case, let's say we're plotting 3. So actually, we'll plot this. So I add my origin, and then I have 3.16 repeating. Since this is less than or equal to, that means 3.16 repeating is included in our solution set. So what that means is we do a closed circle since this is equal to. If it was just less than, it would be an open circle. And we would go to numbers that are less than 3.16 repeating, right? This arrow is just all our possible x values. And that's our final problem.